In this video, we're going to learn how to calculate descriptive statistics. And there are two types of descriptive statistics. There are measures of central tendency and measures of dispersion. Measures of central tendency include the mean, mode, and median, and measures of dispersion include the range, variance, and standard deviation. In this video, we're going to learn how to calculate both of them. Before we can learn how to calculate the measures of central tendency and dispersion, we need to go back to our discussion on samples and population, statistics, and parameters. So remember that we are trying to estimate the population parameters with our statistics. So say we wanted to know what the average of a score was for a population. What we want to know is mu. This is the Greek symbol mu. It is the population mean. We don't know what this value is, but it is a value. Remember, I was joking when I said that this population mean is written on the back of God's hand or the back of the moon. Since we know this value exists, but we don't know what it is, we can estimate the population mean from the sample mean called X bar, or sample mean. So this is the symbol for the sample mean, is an estimate of the population mean. Now this could be a good estimate or it could be a poor estimate. In terms of measures of dispersion, we might want to determine the population variance. This is the Greek symbol phi. So phi squared is the population variance. It's a measure of how different the scores are from one another. We can estimate that using the sample variance. So this is an unknown value, although it exists. Because we don't know what it is, we can estimate the population variance from computing on our sample data the sample variance. And we may also want to know the sample standard deviation, known as phi. We can estimate that from the sample standard deviation. So we may want to know what the population standard deviation is. Again, we can estimate that from our sample data by calculating the sample standard deviation. Now, the first thing that you always want to do when you are analyzing data is you want to make sure you have ordered data. So I'm going to use the first 10 scores from the 2001 CDC College Risk Behavior Survey. Remember, these are the BMI scores for the subjects. I'm only going to use the first 10. So the first one was 23, the second one was 20, and then we have 36, and then we have 20, and then we have 33, and then we have 27, and then we have 23, and then 24, 24, and then finally 18. What we have here is the raw data. So this is just the data from the data file. What we want to do is put it in order form. In other words, we want to have ordered data. So what we want to do is put the data from lowest score to highest score. So we're going to do 18, and what I like to do is kind of check it off here. And then the next highest score is 20. And you'll notice we have two 20s, so we're going to write 20 again. And then the next one is 23. And so there's 123 there and 123 there, so we'll write down that 2 times. And then the next score is 24, and there's 2 of those. And then we have 33. And whoops, no, we have 27. Let's go back and erase that. So sometimes if you make a mistake, just go back and erase it. So we have 27, and then we have 33 and 36. So now we have our ordered data. So we put our data in order from the lowest to the highest. So that's something that you want to make sure that you do when you are presented with a distribution of scores or a set of data. Now, what we want to do first is maybe calculate the sample mean. The formula for calculating the sample mean, or x bar, is the sum of the x of i's, or the sum of the scores, divided by the number of scores. So the sample mean is equal to the sum of the x of i's over n. So this is the formula for calculating the sample mean. What we want to do, and remember, calculate these statistics as I show you how to do them. Don't come up with your own fancy way. Do it exactly as how I show you. So the first step I like to do is I will make a column of all of my x sub i's. So I'm going to make a column of all of my x sub i's, and I'm going to put that in order data. So again, I'm going to have 18, I'm going to have 20, and then 20 again, and then I'll have 23, and then I'll have 23, and if you need to, you can follow along, 24, and then 24, 27, and then 33, and then 36. Notice I've made a nice neat column of x sub i's. And then again, you can follow along, and what I want to do at the bottom is put down the x sub i's. So my x sub i's, if I sum up all of these scores, sum the scores, then I'll have 248. You can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So my sample size is 10. Now I can do my calculation. The sample mean is equal to the sum of the x sub i's over n. So I'm going to show the formula first, and then so x bar is going to be equal to 248 divided by 10, and so the mean BMI scores, the sample mean BMI scores, is going to be equal to 24.80, and I will circle my final value. So I estimate, based on these 10 scores, that the average BMI for college students is 24.80. Remember that this sample mean is only an estimate of mu, or the population mean. It could be a good estimate, or it could be a poor estimate. The next measure of central tendency is called the median. And the median is noted by an uppercase M and a subscript E. To compute the median, we have to have our ordered data. So let's put our data for our 2001 BMI scores, just the first 10. So if we put that in ordered form, we'll have 18, 20, 20, and then we'll have 23, 23, and then we'll have 24, 24, and then we'll have 27, 33, and 36. And again, you can follow along. The median represents the exact middle score. The only way that you can calculate the median is by first having your ordered data. And so you'll notice here that we have two exact middle scores, 23 and 24. So in that case, because we have two middle scores, what we can do is take the two middle scores, 23 and 24, and divide it by 2. And that will give us 23.50. So in this case, my median is equal to 23.50. And I'll circle my final answer. Remember, carry out all your final decimal places to 2 significant digits. Now, another thing that we can get from this data is we can also take a look at the mode. So another measure of central tendency is the mode, and let me erase this here. So the mode is defined as the most frequently occurring score. The most frequently occurring score. So you can see that 18 occurs once, 20 occurs twice, 23 occurs twice, 24 occurs twice, 27 occurs once, 33 33 occurs once, and 36 occurs once. So in this case we have multiple modes. So the mode is going to be just noted as mode, and we're going to have multiple modes of 20, 23, and 24. Now let's just say, for example, we had another score that was here that was 24. In that case, we would have a mode that's equal to 24, because 24 is the most frequently occurring score. So sometimes you'll have multiple modes, but most of the time you'll have one mode, which represents the most frequently occurring score. Now, whether we're calculating the mean, median, or mode, all that does is tell us what the data tend to do. That's why we call it the measure of central tendency. So it just tells us on average or kind of what the data do. But one of the problems with the mean is that the mean is greatly influenced by extreme scores. One of the problems with the mean, particularly the sample mean, is it is influenced by extreme scores. So let me give you an example. In 1999, we had the data for the tax returns in Claremont. Now, if you've ever been to Claremont, you know it's kind of an upper SES, well-to-do city. It's a small city that's kind of in eastern LA, and most people in Claremont have at least a college degree, if not a graduate degree. And one of the things that they found when I looked at the data for from 1999, is that the average household income was well over $320,000 a year. And I thought to myself, wow, those people in Claremont make a lot of money. But this would be a lot of money. This means that a dual earner income, say a husband and a wife, would both be making well over $100,000. Now, even though you might assume that both partners have college education and they have good jobs, this seems to be much, much higher. Contrast this with like Riverside, where the average household income is like $86,000. So I'm sitting there going, well, wow, how can this average be high? Well, when I plotted the data, of course, the data was positively skewed. That is, most people were making around the average here. And what I found out is that if you look at the 1999 data in Claremont, there was one person, the last score way out here, where that person had made $22 million. The next score that was out here was $6 million. So what sometimes will happen with an extreme score, so this is an extreme score, it's well above the next score. When you have these extreme scores, it tends to pull the mean in that direction. So if this person would not have been here, there would have been no $12 million score. The mean, if you took that out, would have been, the average salary that is, would have been around $160,000. Now I would buy that the average household salary in Claremont is $160,000. So that means maybe each one of them are making $80,000 a year, and in 1999 that was really, really good money. Now, the point that I'm making here is that extreme scores, either on the high end of the distribution or the low end of the distribution, can influence the mean. So if you had a couple of scores of 0, but pretty much everybody else was over here, then the mean is going to be pulled in that direction. So one thing you want to make sure you do when you want to describe a set of data is make sure that you calculate the mean, calculate the median as well, and report the mode. Because if the mean and the median and the mode are all the same, then you know you have two things going on. One, you have a normal distribution, and two, there are no extreme outliers. These outliers will cause us a problem, mainly because if there is an extreme outlier, the sample mean that we calculate that data will not be a good estimate of mu. It will be off by a lot. That's why you'll see when people often report home values, they never use the mean, because there may be one house in that community that is worth $22 billion. And so they will report the median, because the median better reflects the costs of a house in that particular area. The mean would be a statistic that would kind of confuse people. So anytime you want to describe what the data tend to do, you need to use all three measures of central tendency: the mean, median, and mode.